User interface code is temporary. It will eventually be rewritten. The database stores the permanent memory of your product. Let's look at a practical scenario. We are going to build a task manager. Before writing a single line of code or letting an AI agent generate tables, we have to map out the core concepts. We start by isolating the main entity we need to store, the task. If you skip this conceptual step and start guessing at the structure as you code, you create long-term problems. You end up with broken data relationships, painful migration processes, and eventually silent data corruption. To make this entity useful, we add slots for an ID, a title, and a description. We assign precise data types, a UUID for the ID, structured text for the title, and exact timestamps for the creation date. Next, we establish constraints by determining what information is strictly required. A task without a title holds no value, so that field is locked down. The description, however, can safely remain optional. These rules must be enforced at the database level. If you rely solely on your front-end UI to protect data integrity, a single API bypass will corrupt your records. Ultimately, the database is the final authority. An entity rarely exists in isolation. We build connections using foreign keys, adding a project ID and an assigned user ID to the task. Avoid vague names like thing ID. Precise names ensure anyone reading the schema immediately understands the architecture. We also manage how a task changes over time. By defining a strict lifecycle constraint, limiting the status to exact values like open, in progress, and done, we control the work state. Enforcing these relationships strictly in the schema prevents impossible data states. A task can never be marked completed if it is missing a valid project connection. We also have to plan for data removal. What happens to the system's memory when a user clicks delete? You have two options. A hard delete permanently wipes the record from existence. A soft delete marks the record as inactive, keeping the raw data intact behind the scenes. For a task manager, history is important. Using a soft delete preserves your audit trail. It ensures that historical reports don't break when old, completed projects are reviewed. To test data retrieval, if you query all in-progress tasks for Project X, which fields require an index? Pause and think about it. You need indexes on both the project ID and the status. This allows the database to isolate exact records without scanning every single row. This finalized schema for the task entity works perfectly together. Because this sound foundation is structurally stable, it's safe to extend later. When building AI features, you can seamlessly add fields to log prompt versions without breaking existing constraints. When designing a database, follow these rules. Model real relationships. Use clear names and strict constraints. Plan for the data's lifecycle, and preserve history where it matters. Investing in deliberate, strict database design upfront guarantees your software remains queryable, maintainable, and safe as it grows.